All right, hello there. This is Piecewise Functions, day 2. Now, we're going to stick with the same concept and we're doing the same work. However, now that we've spent a few days doing it, I'm going to try to gain a little deeper understanding so we can use a little shortcuts. All right, once we understand exactly what's happening, it shouldn't take as long as building a T-chart every time. So this second video is to show those of you who are interested in the shortcuts. In the event you're not, you're welcome to stick with the T-table. It just takes a little more time. So, looking at our first one here, we're only going to do one example, and we'll be sure to review it the next day in class. So I have y equals 5/6 times x. Now, remember our vital point again, it says if x is less than -6. So when x is -6, y equals, well, 5/6 times -6 would be -5. So we're going to have an open dot at -6, -5. Now, from there, I can apply the slope of 5/6. If you kind of think of it like this, if there's an imaginary line here, and I want to be less than -6, what side of the line should I be on? Well, in theory, I should be on this side. Now, 5/6 is a positive slope. So what that means is my line is going to rise from left to right. So I can apply a slope. I can go down 5, 1, 2, 3, 4, 5, to the left 6. 1, 2, 3, 4, 5, 6. And that is my line. Now, let me explain this a little further. If you're ever confused, think about it. If I were to graph this line here in slope-intercept form, well, I would put a dot at 0 because that's my y-intercept. Let me use a different color here. I'm going to put a dot at 0, and then from there I would go up 5, 1, 2, 3, 4, 5, to the right 6. So this would be my line, my entire line. All right, and think of it. I only want it when it's less than -6. So I'm going to take away all the information except for that exists to the left of -6. And that's why we actually applied a slope of -5 to the left 6. All right, so we actually made both of those negative because we wanted to stay to the left side of the line. Again, once you get used to this and you understand it, that's easy to graph. You find your point of interest, which in this case was -6, -5. Plot your point, apply your slope, done. All right, now moving to the second one, we have y equals -2x minus 2. Now here we have two endpoints. All right, so here we have the constraints. So all we really have to do here is find our two endpoints and then draw the line that's between those two. So here we have when x is -6, when x is -6, what does y equal? Well, -6 times -2 is +12 minus 2 would be 10. And then when x is 3, -2 times 3 is -6 minus 2. Y is -8. Please keep in mind that at -6 we have a closed dot, and at 3 we have an open dot. So -6, 10 is here. 3, -8 is all the way down here. And that's an open dot. So we really just need to connect those between there. And that's that line. Now, let's apply our shortcut again and see if this one's a little easier. So again, we still have to find our point of interest. Here, they wrote it a little differently, but no biggie. When x is greater than or equal to 3. So we're looking at to the right of 3. So when x is 3, y is, well, 3 times 1/3 is 1, plus 3 is 4. So 3, 4. Now, from there, we have a positive slope, and we're looking at the right. So a 1/3 would rise from left to right. So I'm going to go up 1 over 3. Up 1 over 3. And that's my final line. Again, once you're comfortable with it, that method's a bit easier than building the T-chart. And here we have a closed dot because it was greater than or equal to. All right, that's it. This is what we're going to focus on tomorrow in class, so be ready. Thanks.